Welcome back, friends and neighbors, to Unit 6 Coordinate Geometry. This is Lesson 7 video for all you cats out there who have been surfing the web and maybe not doing it right. So hopefully she has a power source somewhere on that wetsuit. And that is a waterproof computer. Don't know if that exists, but great picture. Okay, let's get into it. First of all, we're looking at a parabola. You've seen parabolas before. You know what they look like. They're U-shaped structures, and they typically tend to look like this, or up or down. But we are redefining parabolas today. It's a set of points. So a set of points right there. That is equidistant. Check it out, equidistant. In other words, it looks a lot like what we've been doing before with the distance formula and circles. But it's from a given point to a line. So what that really means, when you think about that for a moment, a given line and a point, what that really means is if there's a point on the parabola, like so, and there's some point that's like a focus point, and then there's some point on this directrix line, that's actually what this is. A parabola is a set of points where the distance between that focus right there and this directrix line right here are equal. So let's get into it, shall we? We shall. Spider. Oh, just kidding. Never mind. This just illustrates the point right here of the definition of a parabola. It's a notice and wonder, but besides the fact that it looks like a giant spider, makes me think of Australia, the land of many things where it can kill you. If you just check the distances right here, and you say, oh, that distance from that directrix line, because that's what this line is, it's called directrix with an X, kind of like tricks for kids. From that point over to this focus point, same distance, it's the whole point. D equals D, all right, and that's D1. If you go over to another, take another point, any point on this thing, that distance from the point to the directrix line and the distance from the point to the focus should be the same. That's the idea. Call that one D2. And if you take a look at all those points that are equidistant, here they are, it's a set of all of them. This isn't all of them, this is just a sample. That's what you're talking about. You're looking at a curve like such. Connect the dots with a little curve, that's a parabola. That's its definition. So there you have it. You don't even need to notice and wonder, you just need to pay attention to the video. All right, let's get a little further along here. If you weren't in class, we went to Desmos.com because we really looked at a parabola and we defined it using this equation. Y minus c squared equals x minus a squared plus y minus b squared. And what those were A and B were the coordinates of the focus. So right there, that focus point, that was our coordinate. And then the C was the directrix line. So it's kind of like a Y equals C thing. And if you're looking at this formula and you're saying, hey, how come there's X's on the right side but not the left side? It's because that directrix line from the point to the directrix on the outside of the parabola comes down in a vertical line. The x's don't change at all. Therefore, there is no change in x. So with that being said, go to Desmos.com. You can play with that and have some fun with it. Or email me and I'll go have some fun. We'll zoom on that one. Okay. So let's see what we got. Let me take a look at this in depth a little more, and here's where we go. There, bigger. Okay, so we got our focus point. We can see it. It's right there. It's the point 6, 4. So we can see those coordinates. All right, it's right there. And we can see our directrix line here. In this case, they say it's the x-axis. That's y equals 0. That's right here, y equals 0. It's a set of points, straight line, where y is always equal to 0, horizontal line. So they say it looks like the point 11, 5 is on the line. Determine. Forget the word determine. Prove it. And to prove it, we prove that the distance from that point to the line, to the focus, so let's focus here for a moment, 11, 1, 2, 3, 4, 5, is right there. It looks like it's on there, but we need to prove it. So we need to prove that the distance from the focus to that point, and then from that point down to the directrix, we need to prove that those are equal. So that's what we're trying to do here. So we're just using our version of the distance formula without the square roots. It's the same thing we use with the circles. It's this. Y minus c squared equals x minus a squared plus y minus b squared. And all the a's, b's, and c's are, like we said in the last 2 minutes of the video, are, let me go back in here, 0 right here, that's c. That's that directrix line. So this right here is y equals c. That's where your c comes from. Your a and your b come right here from the points from the focus point. So all we're doing is substituting in coordinates. All right, x and y, those are any point on the graph. So we've got x and y right here. So let's fill in the blanks and calculate. It's really just, at this point, arithmetic. If you get the idea, you get the gist of the formula. So right here, this y minus c, that's right here. That's this piece right here. And the rest of this is the distance from this piece right here. That's the distance between those two coordinates. All right, so that's a and b and x and y right there. I'm going to back this up a hair, and let's do the math, shall we? Okay, so y is 5. 5 minus 0 is still 5. Square it, you get 25. Okay, so that's the distance between there, but it's really the distance squared. I mean, it really is. We squared both sides, so that's what we're checking here. Just, we avoided the square roots. Okay, let's see, x minus a. X is 11. A is 6. 11 minus 6 squared. All right, that's 11 minus 6 is 5. 5 squared is 25. And then plus, right now it looks like this point is not actually on the curve, but let's figure it out. Y minus b. Y is our 5 right here, and that is our coordinate point, coordinate on the point on the parabola. Minus 4, which is our y coordinate of the focus. Squared. Well, 5 minus 4 is 1. 1 squared is still 1. So we end up with this 25 equals 26. And I know what you're saying. No, it doesn't. Mr. Miller, you're insane. You're right. No, I'm not insane, but I am right that 25 does not equal 26. Therefore, that point is not on the parabola. Those distances have to be equal for that point to be on that parabola. If they're not, you must say, no, it's not on there. All right? So let's go continue on here. The summary kind of shows us that spider diagram again, but just all filled in. So the summary kind of really demonstrates those distances. And something to notice here that you might notice or you might not is that when you're looking at the focus and the directrix, if you go down from the focus right to this point right here, that's a point we call the vertex. All right, so we have seen that before. And then if you continue on down, you go down to the directrix, right there, that's why those y coordinates, or excuse me, those x coordinates are the same. And the y coordinate is really just half the distance. It's really, those distances are the same. So from the directrix line down here, we call that y equals c usually. Those distances from here up to the vertex, and then from there up to the focus are the same. You're going to need to use that in later lessons. That's a key valuable piece of information that will save your life at some point. All right. And then bottom line, it's all about the distance formula. Two distances. Calculating the distance between a point xy on the parabola and the focus point, which we call hk. And then the distance between x and y and the directrix, which we can call the directrix, actually, the directrix is just y equals. That's why there's no, that's why that question is asked on there, why there's no x's in it. So we're going to stop right there, call it a day, and leave it at that. Under 9 minutes, not bad. Actually, under 10 minutes. So check this out if you need to. Thanks for watching.